Everyone, 11:05, that's exciting. You probably came to the lecture hoping to escape the heat. I don't know if that's going to be, you're going to have much luck in this theatre. Currently 25.8 in here, but I can feel I feel it's just kicked in. So hopefully it will cool down. All right, hope everyone has had a nice, access is forbidden on the slides. Apologies, okay, here you go. There you go, available now. Okay, so, yay, we're in week 4. So last week we talked about style, we talked about arrays, which was very exciting. So one-dimensional arrays, we talked about functions as well. So you'll be using a lot of functions from now on. And there's a lot of functions in your assignment that you will have to write and you will have to use, and you will get marked for it too. And then today we're going to do a recap of arrays, do a few more questions with one-dimensional arrays, and then we're going to look at an array of structs just because sometimes it really throws people, so we'll do an example with that. And then we're going to start looking at an array of arrays, so a two-dimensional array. So an exciting day ahead. Okay, code for today. Now, assignment 1. Everyone has been, well, just me, but exciting stuff. Assignment 1 will be released today after the lecture, probably at about 2 o'clock. And it is going to be CS defense. It is going to be something that's based on tower defense games. Don't worry if you've never played them before. You're about to waste a good 4 hours of your life. And then more when you actually do the assignment. But basically, it's going to involve you working hard with two-dimensional arrays and manipulating them, printing out of them, doing a whole bunch of things that are quite exciting. But it should hopefully give you a very good understanding of two-dimensional arrays when you finish this assignment as well, and will, get you in good stead as well for the assignment. Okay, so the assignment is going to have 4 stages, and each stage really ramps up with difficulty. Just like the lab exercises, the stages are also 1, 2, or 3 dot. There is going to be a challenge that's not worth any marks, just for funsies, for those that have finished a bit early and want to, attempt to really hurt themselves. That's fine. Please go through the stages one by one because the stages build on each other, so it's important to not skip any stages. And again, keep in mind that you might not be able to do some of stage 3 or all of stage 3. You might not be able to do stage 4. And that's okay. Stage 4 is not worth a lot of marks, but it's going to be taking a lot of time for you to actually do it. So, weigh up where you're at and what you want to achieve. It's still possible to get very good marks by doing stage 1 to some of stage 3. So, keep your sanity as well, but also have fun with it as well. So tomorrow we're going to have a bonus live stream, but also in person situation. And what we're going to do tomorrow at 2 o'clock, we're going to go through the assignment with you. We're just going to run through all the stages, show you how to get set up, show you how to get the starter files on, and to kind of orientate yourself around what's going on. And then we'll talk about, what it is that you're actually doing in there. So that's tomorrow at 2 o'clock. Or you can tune in on YouTube live as well. There's a link for it on our website as well. Okay, any questions? Yeah.
Do you know what day the assignment will be due?
The assignment will be due on Monday of week 7. So at 8 o'clock. So that means that you will have flex week to relax with the assignment, which will be super fun. So it means you'll roughly have 4, 5, 6, so 3 weeks to do the assignment in. One of the things I do want to say is please, 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 please start the assignment early, even if you just read through it and start to kind of get stage 1 going, because we can help you. We run a lot of help sessions. Once it gets to week 6, The help sessions can become completely overrun by people starting their assignment late and needing help desperately. Please start early to give yourself a chance to be seen in time and also to progress through the assignment. Because you can also ask questions in your labs as well. So you're giving yourself the most possible opportunity to do well and to actually understand what you're doing. So please, please, please start early. That is my biggest kind of hint. Yeah?
You said Friday, week 7?
Monday, week 7.
Monday, week 7.
Yeah, Monday, week 7 at 8 p.m. And then the next assignment will get released later that week as well. So there's no breaks. This is it. It's going to be like, we tried to give like a 2-day break between assignments, and then really that's it. It's hey? Yeah. It's like a token 2 days, so you can rest up. Okay, let's recap the arrays and let's do, is it an online submission? Yes, how many hours will it take to finish approximately? Every person will be different. I can't tell you how many hours it will take you. All I can tell you is that the later stages will take a lot more hours than the earlier stages, but perhaps the earlier stages will still take you a lot of time whilst you try and understand what is going on and what you're meant to do. So don't try and judge it in terms of hours or lines of code that you've written. It's really just kind of solving the problem that you are given and, working through the assignment at your own pace. There's, welcome to programming. There's no way we can ever give really times because all of us are very different and we solve problems differently and we understand things differently. Okay, you will get, someone's asking online, do we get a marking guideline? Okay, so part of the assignment, 20% of the assignment is a style mark, okay? That is, a gift to you, basically. Follow good style and write functions, and you will get most of those 20 marks out of the 100, okay? And there is a marking guideline for that as well that we make available, so you can actually check and you can make sure that you're meeting everything that there is to meet for style in the assignment. Yeah, is there a penalty for heavily nested loops? You shouldn't be nesting within a nest, within a nest, within a nest. There's a penalty for nesting, 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 nesting.
What's the maximum amount of nests?
It's in the style guide, yeah. So you will, someone's asked a good question. Is a style mark irrespective of how many stages you complete? Oh, okay, that's a very good question. So if you have not really managed to get through stage 1 and you can't even compile your code, you will not be able to get style marks per se, but we will manually assess your code using, kind of like trying to make it work as much as we can. And we will kind of go from there. So if you can get stage 1 working and some of stage 2, then the style will kind of kick in as well. Okay, auto tests. Yes, there are auto tests in the assignment. Don't worry, we're not leaving you, to kind of flounder about. Not as many auto tests for stage 4 and stage 3 as there are for stage 1 and stage 2. So, and then our auto marking will have different tests to the auto tests that you have. So just because you've gotten full marks or like you've passed all the auto tests, it doesn't mean that you will get full marks for your auto marking. So think of boundary conditions all the time. So in the assignment, we don't give you every possible boundary that we can think of. You can think of, yeah.
Do we know what the auto test values are?
Okay, I think I understand. So the question was, do we know what the auto test values are?
Do we know what to test next?
No, you will just have to think about your boundary conditions. You can see what the auto test is testing because it kind of lists the inputs. You'll see what you failed. You will see what potentially you should. Always just test boundary conditions and edge cases, and then you will kind of get there. Yeah, okay. And you are told in the assignment spec, you will be told exactly what it is that is assumed, exactly what it is that you need to test for. Any error checking that you need to do, you're told that you need to do that error checking. So there's no surprises. The spec is not there to trick you in any way. It's really there to set out an assignment, and it's a pretty, biased, but it's a pretty clear spec with what it is that is required of you and how, and what you need to do. Any other questions about the assignment? Yeah.
What level of help
Okay, that's an excellent question. So the question was, what level of help are the tutors allowed to give? So for stage 1 and stage 2, we're allowed to give you quite a bit of help, okay? As in, we will draw a diagram. We will not obviously write the code for you, but we will draw you a diagram. We will direct you to a similar exercise perhaps in the lab. And there are going to be some exercises that are similar in next week's lab that will help you do the assignment. We will direct you to that. We'll direct you to any lecture content that's relevant, but we will also help you to get through stage 1 and stage 2. The help will reduce for stage 3, and we will offer you barely anything for stage 4, unless there's no one in the help session and we can kind of talk to you. But if there's someone in that same help session that requires help with stage 1, we will prioritize them over you if you're at stage 4. But then go to your labs, use your labs as well. The tutors there can help you, your tutor, your lab assistant, they can help you in the labs. Okay, so I think that's, you know, if you do stage 1, stage 2, and you do nice style, you'll be getting, it's like a credit or a high credit. So we did the marking guide, so it's possible to do quite well without kind of, you know, getting into the stage 3s and stage 4s. So it's up to you what, you know, make your decisions based on how much time you have and how much time you want to spend and how much time you need to just rest as well, which is quite important. Is it a fun assignment? It is a super fun assignment. Again, a biased opinion, but it is really fun, I think, again. Hopefully you think so too. Yeah, any other questions about the assignment before we move on? I'm not gaslighting. I thought it was fun. The few tutors that tested it also thought it was fun. Confirmed I will not touch grass for the next few. I don't know which grass, but yeah.
Finish a stage, does that still get marked? Or?
Yes, because you will still pass some of the auto tests, some of the auto marking. So yes, part stages are fine as well. And each stage is broken up into smaller components to really kind of give you, you know, a more structured approach to it. Okay, so please, please, please come and, you know, come and kind of do help sessions as well as you need. The weighting of the assignment, 20% off your course mark is this assignment. And the next one is 25.
Are there only those 2 assignments?
Hey?
Are there only those?
There's only 2 assignments, yep, and then the exam. Okay, good. All right, everyone is sufficiently excited, I think, about the assignment. Okay, I'll leave the tutors to answer in the chat for the rest of the questions. Okay, so let's kind of recap arrays, and then we'll go into 2D arrays so that you're able to read the assignment later today, and you can kind of see if you can start at stage 1. Actually, one more thing I want to say about the assignment. So next week, the second lecture, the Thursday lecture, will have a similar problem, like a much smaller version of a problem that you have for the assignment. And we're going to solve it together in the lecture, and it's going to help you immensely to do, you know, stage 1, stage 2 of the assignment, some of those stages. So that's going to be next week on Thursday. So another way to get help, really. Okay, excellent. So arrays. Now, what is it that we should remember about arrays? Who wants to tell me something about arrays? They start from indexing from 0. Yes, I like that. Yeah. Yeah, same data types only. Excellent. What else do we know about arrays? Seriously, Sophia? That's literally 2 seats. Yeah. Yeah. Yeah, so same data type. And then what else do we know? How are they given in memory? Are they like all over the shop or? Yeah. Next to each other. Excellent. So they're given consecutive. Oh, very good. Well done. No heads hit. Someone in the chat is now gaslighting me, saying arrays are cool. I can't throw you a chocolate for that, but arrays are cool. Okay, so that means they are an index data structure, which means that we can access anything easily just by saying what index we want something, you know, something at. So arrays go hand in hand with loops because we need to always kind of pass through the array, so we need to access either every index of the array if we're printing it out, or if we're scanning into the array, again, we're accessing every single index. And that means that we love to use loops in this case. Okay, so should we do a question? Let's do a question. I think it's time to do a question. Okay, can you see at the back? Is that font big enough? No. All right, how's that? Is that better? Yeah, okay, excellent. Hey? Oh, I thought you were saying something. Okay, a user is asked to enter 5 numbers. We will then go through these numbers and find the lowest number and output what the lowest number is to the user. How exciting. Okay, so how are we going to solve this problem? What are we thinking? What's our rough plan? Rough plan? Yeah.
Define a max value.
How are we going to do that? So we want to find the lowest number?
Yeah, just the hash define. Max array.
Okay, yeah, sounds good. So we're going to define the max of our array. Excellent, I like that. Because I said 5, good, and it doesn't change. Anyone else? Okay, should we scan in some numbers?
A way to store a number.
Yeah, so we want to store those numbers in an array, perhaps. Okay, so we'll scan them in, we'll store those numbers in an array, and then comes the fun part, deciding what, going through the array and deciding what is the lowest number. Who has ideas how we can do that? Yeah.
You set 2 arrays with your lower, like your lowest number, then you have a counter, and then you go through the array using the counter. You compare the counter and the lowest. If the counter is lower than the lowest number, then that is your new lowest.
Yep, okay, excellent. So let's say we set our first thing in the array as the lowest item, as the lowest number, and then we pass through the array and compare each subsequent index of the array, what's in there, to our lowest number. And if something is lower, then we set the new thing as the lowest number and continue on. All right, let's give it a whirl. Okay, so we've got our hash define. Okay, and I've declared an int lowest number. Now we need to declare an array. So I'm going to int array. And what will go inside my square brackets? Yeah. Yeah, perfect. So our max. Now I haven't initialized the array here. I've just declared that I will use an array, and really it should be a line down because my comment is saying that I'm declaring it. So let me move that down here. Okay, so I've declared an array. Now I want to initialize it. So to initialize it, I'm going to use a scanf. Okay. Okay, and if I want to store it inside an array, then I'm going to need to do a loop because I need to store things one by one into the array at all the different indexes. So I'll have a for loop here. What should my condition be when I stop? Yeah. Okay, so I'll ask for a number and then I'll scan it into, so I'll scan a %d and I will store it into array at index I. Okay, yeah.
Is there any meaningful difference between I++ and ++I?
There is.
Is it meaningful to us?
It's a very good question, actually, because it's like one is post-increment, one's pre-increment. But I will do it. I will do it. It's the way. It's when it increases the count. Yeah.
Is that like an append function in C?
No. Just get used to, yeah. Okay, so we've gone through, this will hopefully scan everything into the array. So now let's kind of decide where's the lowest number and what we want to do with it. And well, okay, so we've declared something called lowest number. So now we want to actually set that as our lowest item. Okay, so up here at the top, I've declared that I'm going to use this lowest number variable. So now I'm going to initialize it. So I'm going to say lowest number, and that's not going to work because now I have to, there we go, and spelling. Okay, so lowest number is going to be, I'm going to say it's going to be array at index 0. So I've set it to the very first thing in the array. And now I'm going to go around and compare things. Also here, I should really do some error checking, which we haven't really done before, have we? We haven't done it in a lecture for a while. Should we do an error check in here? Let's do an error check. How are we going to do an error check? Yeah, I'll use a scanf return. Okay, so you have seen me do kind of like if scanf return, like do int, declare a new thing, int scanf return, and then I kind of read that, then I do an if and move on. And that's great, but what I can do is I can shortcut it just by saying if scanf return here is equal to, well, it's equal to 1, then I'll do whatever. If it's not equal to 1, then something has happened. And let's see what has happened. So what I'm doing now is I'm doing the error checking in here. Okay, so what this will do, and we will run through it line by line in here, and if you want, I will break it down again into having a variable and then checking that variable outside. But if that scanf%d is not equal to 1, which means it hasn't scanned in a number in there, it might have been a character or something else, then it's going to go inside this if statement. And I might go printf, you did not enter a number. And then I'm going to return 1, which means that, you know, exit out of here, no number was entered. Obviously, there's a variety of things you can do. You can also just ask them to enter a number again and give them a chance to try again. But I'm just returning 1 so you can see a return of 1. Yeah?
If not exactly the same as this, but if instead of saying if scanf is not equal to 1, if you want to say, if you want an if loop where the condition was scanf being equal to 1,
yeah.
Can we do the similar like shortcut like we can in Python where we can just say if scanf whatever?
Yeah, so you can say, what, yeah, yeah. I just didn't want to put everything inside the if statement, which is why I did not equal to 1, the opposite. But yeah, you can absolutely do that. Because the return of this is going to be an int, right? So all I'm doing is I'm calling it from over here, calling this function, but it returns an int, which means something will be returned here, and it's either going to be 1 or it's going to be something else. It's going to be an int, basically. Okay, so then I'll make my lowest number equal to the first element of the array, and then I need to go through the array again. So I'm going to loop through it again, and I'm going to have the same condition. So I'm going to traverse through the array, and what I'm going to do is I'm going to do a comparison now. So I'm going to check if my lowest number, so my lowest number is greater than, yep, yep. Hey?
Lowest number.
Yep, I did it again, yep. Thank you. I just don't want to put an underscore today. Okay, so if lowest number is greater than array I, what that means is I've got a new lowest number, haven't I? Yeah. You
are redefining I there.
Hey?
You are redefining
I am redefining I, yes. I don't have to do that. I could just do, yeah.
Wait, if you only define I
inside the for loop.
Yeah, inside the previous for loop.
It's not going to.
It's okay to say int, right?
Yeah.
But then if you had declared I outside the.
Then I would have to. Then I would just do I is equal to 0. Yeah, because it's me redefining it. Okay, so then my lowest number is, oh my God, again. Just refusing to do an underscore. Then lowest number is going to be array at index I. So I've changed it out. And then let's print out something. Printf the lowest number is blah. lowest number. Hey?
No, sorry.
Yeah. I swear there's an underscore here. I swear. Okay, let's see if it compiles and runs, and then we will go through it line by line. Okay. I also just really want to, that's I'm in the wrong directory now. Can you, actually, you probably can't see can you see the code? Did I chmod the code? Probably not. Did I give permissions for the code? Oh. Wow, I'm impressed. I love spelling. This is why I did computing. Okay, here we go. I'm back. Thank you. I keep trying to make it easier, so I'm shortening the file names. Okay, there we go. Everything compiles. Let's see if it actually works, and then we'll go through it. Okay, let's do 1, 2, 3, 4, 5, and then it's saying the lowest number is 1. Okay, so it's doing it correctly. Maybe, we don't know. We could break it. We didn't actually test it. I literally did something that it's meant to be doing. All right, let's run through it as a piece of code, and then we can see what it's doing as well. Okay. All right, let's do it. Okay, excellent. So first one, line 20, you've got a variable called lowest number. I've declared it. There is no value to it. Then I have an int array max, and this max is a hash define of 5, which means what I have is I have array 0, array 1, array 2, array 3, and array 4. Okay, great. And they're all consecutively located in memory. Then I go into my for loop. I've got an int I is equal to 0. So I've got an I, and I've initialized it to 0. Until I is less than max, I'll check my condition. I is 0. Is it less than 5? Yes, it is, which means I'm going to go into this loop, and it's going to print out, please enter a number. And let's say we're entering 1, 2, 3, 4, 5, which I entered before. So if scanf%d and array in here, so currently my array I is 0, so we're scanning into the 0th index of the array. And I've entered 1, which means that this case is not true here. It's not, it is equal to 1, which means I don't have to do anything inside this if statement. But what it means is into the 0th index, I'll get a 1. And then I'll go straight through up to the top, increase my I index, and then run the check again. So I'll check, is 1 less than 5? Yes, it is. I'll do the printf. Then I'll do a scanf in here. So I'll scan into index 1. And at index 1, I entered a 2. So that will go in here. I won't do this if statement because it is equal to 1, so no problems. So I'll go back out. I'll increase my index by 1. And then I'll check it again. So I'll check, is 2 greater, less than 5? Yes, it is. So I'll go back into the loop, enter a number. The next number I'm entering is 3. So at index 2, array 2, I'm going to scan in the number 3. And then I'll increase my index by 1. And I'll check again, is 3 less than 5? Yes, it is. So I'll go in here again. I'll print out, please enter a number. I'll scan out this. So now it's going to scan into index 3. And at index 3, it's going to scan in a 4. I'll increase the I by 1, and then I'll check my condition again. So now, is 4 less than 5? Yes, it is. So I'll enter this loop again. I'll print out, please enter a number. And I will scan into array at index 4 now, because I is equal to 4. So I'll scan in the number 5, and then I'll increase by 1. I'll check my condition again. Is 5 less than 5? No, it's not. So I'm finished with this. I'm finished with this situation now, which means this is now gone because I've come out of my little loops. That's not what I wanted to do. Okay, let's lower it down a little bit. Okay, and so now I'll keep going down here. So now I've got a new variable, and oh no, I have it already declared, but I've initialized it to whatever is sitting in array at 0. So what's sitting inside array 0? It's 1, and that means I'm now assigning 1 to lowest number variable. I will now go to line 34, and I'll go again. Okay, I've got a new I here, and I'm going to do this I again. So I's, and I've initialized it to 0 until 0. So first condition check is 0 less than 5. Yes, it is. So that means I'm going to go inside this for loop. I've got an if statement here, so I'm checking is lowest number. So lowest number is 1. So I'm checking is 1 greater than array at index I. And my array index I is 0, so I check it against array 0, which is 1. Is 1 greater than 1? No, it's not. So I'm going to increase I by 1. And then I'll check again my condition. Is 1 less than 5? Yes, it is. So I'm going to go in here. And now I'm going to check my lowest number is still 1 over here. But now my array is 1, which means I'm looking at this number over here. So I'll check, is 1 greater than 2? No, it's not. So I won't do what's inside here. But I'll go out and I'll increase my I by 1 again. And that means I'll now check, is 2 less than 5? Yes, it is. I'll go back in here. My lowest number is still 1, but array at index 2 is equal to 3. So then I'll check, is 1 greater than 3? No, it's not, so I won't do inside the if loop. I'll just increase my index, my I, by 1. And I'll check again, is 3 less than 5? Is 3, no. Is 3 less than 5? Yes, it is. So I'll go inside here, lowest number, still 1. And then is it greater than array at index 3, which is number 4 in there? So I'll check, is 1 greater than 4? No, it's not. Increase I by 1, so it becomes 4. Check my condition again. So is 4 going to be less than 5? Yes, it is. Go inside here. Lowest number still 1, but now I'm at index 4, so I'm checking it against the number 5. So is 1 greater than 5? No, it's not. So that means I don't go into this if loop again, but I increase my index by 1. I check my condition. Is 5 less than 5? No, it's not. So then I don't have to go in here again. That's now gone. And then I go into here, printf, the lowest number is placeholder, lowest number, which is 1, which is perfect. Return 0, all of these goes once I come out of the curlies, and done. Okay, so let's see if it works for a different case. Let's see what happens if we return, if we force it to go inside this situation here. If we force it to go inside this scanf and we give it something that's not a number. Okay, so what I'll do is I'll run it again, and this time I'll go 1, 2, 3, and then I'll enter a character. And what it's done is it's a character, it's not an integer, so it's gone inside this if statement, and it says you did not enter a number, and then because you've returned 1, it exits out of the program, and it's kind of saying something went wrong clearly, and we're exiting out. Okay, what else should I try if I was testing this piece of code? What else should I try that it's working as I want it to work? Pardon? Negative numbers? Okay. So let's try negative numbers, -6, -7, -8, -3, -6, no, 9. Okay, and it's working for negatives. What else can I try? Very large numbers, okay. What else was there? A float? Okay, we could do that, absolutely. So I'll do a float first, say 3.1, and then it... Sophia's asleep, wow, and everyone else has been going as well. Okay, and what about very large numbers? Yeah, I went to because I was just randomly punching anything in. I went above the limits. It curled about. Excellent, so that broke it a little bit. Anything else I can do? What else would you test it with? Would you like change up the order of the numbers where the lowest number goes? That would be one of your test cases as well. So I might have my lowest number, you know, I tried it at the front. Now I would have it in the middle. and it's still working, then I try it on the boundaries. So I've tried it at index 0. I tried at the opposite index as well. So I'll do 5, 6, 7, 8, and then I'll do the smallest number there. So that works as well. Yeah? Pardon? Yeah, duplicate numbers. That's a nice one as well. Okay, what if I do 3, 4, 2, 3, 2, 2? That's still working good. Excellent. That was a good one to try. So, yeah.
Could you do letters?
Yeah, I did do letters to start with. It will, yeah, it will trigger this if statement to go into. Yeah, yeah, sorry. Okay, and let me just, does everyone understand what's happening in this if statement? Because it's the first time I've moved it into an if statement as opposed to having it as a separate variable. Yeah. Because if you wanted to, because I'm telling it that an integer is coming. And so when you scan in the character, it's reading it as a character. Yes, it has an integer value to it, but it's reading it in as a character. That's the simple, really basic, really way to think about it. Yeah.
What does the return 1 do?
Okay, so the return 1 will basically exit out of this program. It will finish the program. And returning 1 means that something, it did not finish successfully. So it exits out of the program and some issue has occurred. Okay, anyone else? All right, we just did a line-by-line walkthrough, so I won't do it for this one. We'll do it for the next one as well. Any other questions, or is everyone okay? Tom, can you poll? Pardon? I can't hear you, sorry.
No, I mean, how you return the error.
How do I what? I'm sorry, I can't hear very well.
Can we use return 0 instead of return 1?
Okay, so return 0 says it still does the same thing, hypothetically. Okay, it exits out of the program, it returns out, but 0, standard practice for someone reading your code, a human, 0 says everything finished successfully. 1 says something did not finish successfully. So in this case, I've returned 1 because the program didn't actually run. Yeah, it didn't do what it was meant to do. We had to exit out because there was an error. So for a human reading it, this return of 1 will tell them that this branch over here, something has gone wrong on this branch. That's why we return 1 instead of 0. Yeah.
Is there any way to actually use the return value?
Yes.
So you can use main like an actual function instead of just like the place where you put your code?
So we're using 0 and 1. There are hash defines in the standard libraries that basically exit success, exit failure, which makes it even more readable, right? But we're just sticking with 0 and 1. But you can also return, like, let's say you have a list of error codes, you know, error code 100. You can return 100 and it will write to a special kind of like error. You can tell what the error is, if that makes sense.
Okay, I mean, I got that, but I meant like, is it similar to how we can say, you know, we have a particular function, right, which will return 1 if it's odd and 0
Yeah.
if it's even or something like that, right?
Yeah.
And then you can have something like if number underscore check is equal to 1, then printf number is odd, right? Can we do something similar but with main and the
Ah, I see. No, in main you are, because you're exiting out of the function, so you're goodbye. Yeah, yeah. Okay, those are very good questions. How is it 11:45 already? I don't know. Okay, let's do one more. Let's do one more question for practice with one-dimensional arrays, although actually I wanted to do arrays of structs as well and two-dimensional arrays. Oh my God, okay. Let's do an array of structs first, and then if we have time, we'll go back to this one. Because we'll also do, on Thursday, we're going to do strings, which is more 1D arrays, so maybe we'll go back and do this sum even problem. So let's look at array of structs instead, because that will be useful to just kind of go through. Okay, so you can have an array of anything, right? And one of those things, sorry, the lectern just went off. So one of those things is a struct. So you can have an array of structs as well. And all that means is that you're drawing something that inside an array of structs, you are actually housing a struct in each of the array indexes. So what that means is that you can have this different data types inside a struct, and then you can create an array of those structs, and it kind of circumvents the problem that everything has to be the same data type. I mean, even though everything has to be of data type struct. But what it looks like is, let's say you have an array of size 5, and you want it to be an array of structs. So you use the keyword struct coordinate for this, using this structure over here. And what it does is it creates size 5 array, and each index of that array is housing a struct coordinate. So that struct coordinate is going to have an int x and an int y, which means it has two things inside each of those indexes. And you assign again with a dot. So I came up with the most convoluted problem, I think, for this exercise. But maybe I'll just show you very simple how to do it first, and then we can look at the convoluted problem. Okay. So let's say, no, not over here. Apologies. Okay. Okay, let's say over here I want an array of structs. Okay, I have a structure over here, and this structure is called dog, and inside it has 3 components. It has a char name, an int age, and you know what? I'm just going to actually just get rid of one so that it's faster to do. So let's just say it's got an int age and a char size. So we've got a structure dog, it's got an int age, char size. Let's say I want an array of structs, so I want an array of dogs, because who doesn't? Of course. And I'm going to declare it. Okay, so declare an array of structs. To declare an array of structs, I need to say what data type I want my array to be. I want it to be an array that houses struct dog, which means that my data type is struct dog, and then I'll give it a name. And let's call it array dogs, and it's going to have size. I hash defined the size here just to keep it simple. So max. So what this will do is it will create an array that looks like this. So this line over here, actually I'm just going to go back so you can see the structure as well. No, I can't. It's too... There, okay. So what this declaration here will do is it will create an array dog. So it will create an array of size 5. So it will create something that... Yeah.
Reading through the problem, right? So
Yep.
we're using char for size, but then the dog A has a size of XL. So can we just use X instead of XL then? Or?
Yes, that is a very good point. Yes. I'm very keen to get on strings because doing names with just one character has been painful.
Why have we put on strings for so long?
Because it's an array of char, so we needed to do arrays. And then today we're doing 2-dimensional arrays so that you can do the assignment or look through it at least. So strings are coming on Thursday. Okay, so we've got our array dogs. So this array is created, dogs, and it's got size 5, which means it's got 5 elements in here. Indexing is still the same, and it's of type struct dog, which means that inside each of these indexes is going to be my struct dog. So the struct dog has an int age and a char size, which means that inside here is going to be an int age, and this one is going to be a char size. And that's going to be true for each one of them. So it's going to create this kind of structure. So it's going to be int age and char size, and so on and so forth here, and so on and so forth here, and so on and so forth here. So it's going to create this homogeneous structure, which is each one of these indexes is going to house a struct. Now, if I want to assign something to these structs, which I would want to do, okay, so let's say I want to assign to, I don't know, let's assign to the first index. Why not? Okay, So to assign to the first index, I will use my variable name, okay? Now I need to say that I want to go into the first index, which is index 0. Great, that means I want to access this part of my array. But inside this part of the array, I still have an int age and I still have a char size. So I have two options for something I can access. So which option will I take? Which one do I want to do? Okay, let's say I want to do the age first. So I use my dot, which means please access this member of the structure. And the dot allows me to access whichever one. And so now I'll say age, and let's say it's equal to 7. And then if I want to do the other one, I'll go at index 0 dot, and I want to access size. My size is a char, so I might do a medium or an M for medium in there. Okay, so that's assigning into the array of structs. Okay, how is everyone feeling about assigning into structures? So similar as you would normally do a struct, but you're using indexing in the arrays. Yeah. Yes, I absolutely can. Excellent question. So basically whatever I can do with an array, I can do whatever it is that I want. So let's say I'm, I don't know, going to scan into all of them. And so I'll go for int I is equal to 0, I less than max for my condition, I plus plus. And what I'll do is I'll scan into it. So I'll go, okay, print, first thing I'll print might be, did not mean to do that. Please enter age of the dog. Okay, and then I'll scan in. So I'll do a scanf, and I'll scan in a %d because I want the age, and it's going to go into the address of array dogs at index I dot age. So I'm doing it in exactly the same way, but this time I'm being flexible in that the index is going to keep changing the whole time. And then I can do the same printf, please enter size of the dog, and similarly I will scan in, but now I will scan in a char. So I'll scan in a %c, and I will put it into also at the array dogs at index I, but this time I'm accessing the other member of the structure. So this time I'm accessing size instead of age. Okay, so that will fill up the array, and then if you wanted to print it out, then you can do another for loop to print it out so we can see exactly what's going on. So let's say we now want to print this out. Okay, I'll do another for loop to print it out. Int I is equal to 0, I less than max, and then I'll do I plus plus. And what I'll do is I'll printf the age of the dog is blah, and size is blah. And then I'll do a new line for fun. And then in here you'll access again the array at index I, and then which member of that index you're going to do. So the first one I did is the age, which means that I'll access the age member, and then I'll do array dogs. Now I've gone over 80 characters because what a mess, but we'll fix that in a second. And the second one is size. Okay, so that's going to give me that array. So if we run that now, and then we can just quickly go through it. Okay, so let's run it. Okay, let's do for. Okay, and then it's going to print them all out. So the first one was 4 and M, which it's doing, 4 and M. The second one was 3 and L, which it's doing. The next one is 2 and S. And then it was 1L, 1L, and 9 and X. So it's scanning into the array of structs. So you're really using it in the same way as you use everything else, but this time you have two potential things at each index that you can access because of you using a structure and you're placing it inside that array. Tom, can you just do a little poll how we're all feeling about it? Thank you. Yeah.
Would you like to scroll down a little bit on the C code? Oh, thank you.
Okay. Can you, someone's asking on the chat, can we do something to get only one particular output we want? Absolutely. If you know which index you want, then you access that index of the array. So a number of ways to split up the long line. Perhaps I would like to do 2 statements like this. So if I use 2 sets of quotation marks, what it will do is it will split it up for me and it will join it together. It will concatenate those 2 strings. No, this is not a 2D array. That's a very good question. It's just an array of struct. We're about to do 2D arrays after the break. All right. Yeah.
So if one of your elements, sorry, if your array is of type string, even if it's a 1D array, it's technically a 2D array, right?
So it's not going to be an array of type string. It's going to be an array of type char.
An array of arrays of type string?
So it's going to be a char array. And there's something special about strings to signify that it's a string, not just an array of char.
So that's actually 0, right? So like, if you want, like at a high level, if you want a 1D array of strings, right? Technically, that's a 2D array.
I see what you're saying.
Char, right?
Something like that. Yeah. You can. Oh, you're going to have fun. You'll have fun with command line arguments. Okay. All right. I think now is a good time to take a little break. Then. No, we haven't done strings yet. We're doing them on Thursday. All right, let's have a 5-minute break, and then we'll come back and we will do array of arrays and a fake Kahoot, obviously. Oh, what about a fake Kahoot? Let's start with a fake Kahoot. All right. Why don't we use Kahoot? All right, let's get it started. Okay, only the same data type in each array. It is, but the array is an array of structs, so it's all the same data type. Ah, okay. Okay. Oh, oh, that hurts. When you wish you had a piece of paper and a pen. Oh. Oh, that shouldn't have there shouldn't be a code snippet here. Apologies. Just the question. Don't worry about the code snippet. Oh. Yeah. You cannot return an array in C. Whoa. What a variety. Okay. I will start making the questions available afterwards as well, so you can go through it. Oh. I wasn't returning an array, I was only returning an int. All right, who we got? Sophia, you ready?
I'm ready, Sasha. I'm ready.
Oh. D. Ah, nice. Who's Dragonite? No one? Anyone really? Are you? Yeah, yeah. There we go. And then who's, have we got Cool Kid in here? I mean, everyone's a cool kid doing comp, but.
I'm so sorry. That was really bad. You know that one. Someone else did it.
No, stop it. Sounds like stop giving it to me. You're hurting him.
All right. All right. Excellent. Let's talk about an array of arrays. So we've said you can put anything into an array, and what you can put into an array is another array, which is super exciting. And that becomes a two-dimensional array if you have an array inside an array. So the way you want to think about it is basically it's like a grid. It's really simplifying, but that's kind of what it looks like visually. And then to declare an array of arrays, what you do is you say what data type you want. So for example, I'm going to be housing all ints in there. So I will have an int array. And then because it's an array of arrays, I'm going to have two lots of square brackets, okay? The first lot of square brackets is going to give me the number of rows that I have. So it's creating this array here. And then the second lot of brackets is the number of columns, and that's what's growing that array into a two-dimensional structure. So remember, and this is where most of the mistakes happen, indexing still starts at 0. So an array, an int array that's got the size 3 rows, 5 columns, it actually has 0 to 2 in the row indexing and 0 to 4 in the column indexing. And to access any element in that array, you now need to specify the row and the column that you want. And so sometimes it's really useful to draw it out what it looks like, because then you can see what's sitting inside each one of these indexes. So if I want something at row 2, I'll go to row 2, and then column 3, I'll head to column 3. So when I want to access something at array 2, 3, what I'm accessing is this number here, for example, number 2. Okay, and so basically what happens is it works in much the same way as your while inside a while loop as well. So when we printed out a while inside a while in week 2, it was at the end of week 2, yep.
Technically, is it actually like storing it in terms of the rows and columns, or is it, or is the first value a row and the second value a column simply because we treat it as something?
It's because we're treating it as, we're visualizing it as a grid, okay? But it's like, the first part is it creates, like, let's say you want an int array 3, and you specify that it will create that array, and then it will do the 4. So it will place into those 3 an array of 4 into each one. So it looks like a grid, and it's much easier to think of it, to visualize it as a grid, because it means it makes it much easier for you to understand what you're accessing as well. So when we printed out that grid of numbers in week 2, what we did is we kind of went, whilst row is less than size, we reset our column each time so that it could keep moving, and then it could move down each time. And then we increased the column each time. So what that printed out was a grid of numbers that was a certain size, 1, 2, 3, 4, and then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 again, or whatever it is. And so this is similar to how your array of array works as well, because if you visualize that two-dimensional array as though it is a grid, you are still printing out a grid. So you've got a while inside a while loop, or a for inside a for loop. So you've got a loop inside a loop to be able to print out the whole thing, or to access the whole thing. So let's kind of play around with it a little bit just to see what's going on. So if we go to the very simple 2D array, and I'll do it first here. Okay. If I were to declare a one-dimensional array, so let's say I've got array one-dimensional, 1D array, and let's say I'm going to give it size, I'll just do, okay, so let's say I've got a one-dimensional array. This is how we would declare it. And then if we were to initialize it, and this is something that everyone got wrong as well, well, a lot of people got wrong, I can't declare an array on one line and then initialize it like this on the next line. That will not work. After this point on, I have to do a for loop and do whatever it is that I need to do to get things into it. But what I can do is I can declare and initialize in one foul swoop. So I can do this, and then I can place, how many was there? 5. 1, 2, 3, 4, 5. So this is fine. Now, the other thing we didn't really talk about with one-dimensional arrays, I could also do, getting terrible with names. So what I can do is I can do an array here. I've said that I want an array of ints, and I haven't given a size in here, but I've initialized it. If I initialize it like that, it will deduce the size of it based on my initialization. So that's the time that I don't have to specify the size of an array. But if I'm not doing that, if I'm not initializing it, I must give a size so that it knows how much memory it needs. Okay, so that was our one-dimensional array. We kind of did it like that, and it was fantastic. So what about a two-dimensional array? Let's have a look. So if we have a two-dimensional array, we now need to say the number of rows and the number of columns, because it's two-dimensional, it's an array of arrays, which means that you want 2 lots of square brackets, and that means that you now want 2 sizes. So I'll say max row, max column. So that's exciting. Now you've got even more things to worry about. And then what do you think, how can I actually initialize it inside it? I'll still use the curly brackets. Does anyone know how I can initialize it inside there? Yeah. Yeah, so you do them in another set of curlies, okay? So I'm going to go and do, I don't know, I'll do 2, 3, just so that it's easier to see what's going on. Yeah.
Could you initialize them all as 0 by just saying that whole thing and inside the curly brackets just put 0?
Yeah.
So then both the row and column values would be all 0.
Everything would be 0, yeah. Okay, so if I were, yeah.
Is there supposed to be a void in the brackets for the in main, or is there going to be something else instead?
Yeah.
Okay, no.
In the real world, you often forget the void.
Okay, fair enough.
Yeah. But it's a very bad style to forget the void. You really want to be very specific that because you can have other things inside your main parameters. Yeah.
Since you mentioned it, is there a way to pass in a parameter to main?
There is a way to pass in something to main, and it's done at the time when you run your program. So when you're running, /run the program name, there's a way to give it parameters. And we will do that. Okay, so let's say I've got rows is 2, columns is 3. So basically what I'm saying over here is I'm creating an array that's got 2, 3 here. And that means inside here I'll have 2 lots in here because there's 2 rows. And inside each one of them is going to be an array of 3. So let's say 1, 2, 3, and I don't know, 4, 5, 6. Okay, so that will create 2 rows, 1, 2, 3, 4, 5, 6. So what it will look like will be like this. So first of all, it will create 2 rows. So like that, 2 rows and 3 columns. So 1, 2, 3. And then when you put them in, it will look like this. Okay, so that's a way to initialize it like that. Of course, you can also just initialize it with scanf to make it more flexible. There's going to be not that many times in your life where you hard code values into an array because it really defeats the purpose of doing a lot of the programming. So, and don't worry, we will also rehash on Thursday and we'll go through it again. We'll do another problem, so don't worry. Okay, so let's say I've got this lovely array here. It's a 2-dimensional array, and it's got inside it 1, 2, 3, 4, 5, 6. And let's print it out to start with. Okay, so if we were remembering our wonderful while inside a while loop, we're going to do it in a very similar way. Okay, so first of all, we're going to have a for loop that's going to keep track of and I've got an inside loop and an outside loop. So let's say I've got that's not what it is. I don't have a variable. Okay, I'm going to have an int row, int column. What you will see though is that it's perfectly acceptable here also to have an I and a j. Okay, you don't have to have variables that are called row, column, and so on. It's like the only time where you can have these variables that are just one letter. I stands for index, and j is kind of used as a second index to keep track of your rows and columns. So you can do that as well. I'm going to keep it as row and column for now, just so that you can see it, growing and doing something, because it's easier to tell what's going on. So I'll set row to 0, and I'll just initialize column as well to 0. And what I'll do, outside loop, I'll start my row at 0, row until less than max row, which was my hash define, row plus plus. And then what I want to be doing is I'm going to have another loop in here. And it's going to be column is equal to 0. Okay. Okay, excellent. And then let's print out. And then we'll see what it does. Print out %d because we've got we can absolutely use a while loop. I can do a while loop next. And what we're doing is I want to print out of array 2D at row column. Okay, and we'll run through the code, so don't worry. Okay, let's see what happens. Actually, I'm just going to comment out the one-dimensional array that I haven't used. Okay, and let's do that. Okay, so what has happened here? It's just done 1, 2, 3, 4, 5, 6. What has gone wrong? What have I forgotten to do? Yeah. I mean, I could do a /n, but why haven't they? That's not a grid. That is straight up just one line with everything on the same line. How do I make it round up to go into a grid? It would be nice to have a /n because this is ugly. What do we reckon? What do we do inside our while to kind of make it flip and go to the next one? So /n, where would the /n go? Yeah. For the chocolate. Let's go.
Probably up in the row folder.
Yeah? So which line? Which line of code?
Line 33.
Did you say 33? Okay, let's try it here. Okay, if I print it out here, let's see if it will fix it for us. Okay. Aha, very good. Okay. All right. Okay, should we run through it just so that you can see what happened in here? How's everyone feeling? Tom, good? Oh, someone said good. That's nice to hear. Just one person said good. Eh? Okay, let's have a look. Well, I can't hear anything up here. I'm so sorry, everyone. You have to speak really loudly. Oh, I see. Oh, I see. Ah, now it all comes out. Okay, I was like, I should have brought Zupa Dupas today. Yeah, if it's hot. Hey? We can do the scanf. We'll do it after this. I'll run through it now. Then, good idea, we'll do a scanf. Okay, let's have a look. Okay, line 25, what happens is I'm declaring an array. It's got size 2 and size 3 here, and I'm filling it up with that. Okay, I'm going to draw it as a grid because it's starting to get hard to list out all the variables that we have. But 0, 1, 0, 1, 2, okay, and it looks like 1, 2, 3, 4, 5, 6. Okay, so I've initialized this now. Then I've got a variable called row, and I've set it to 0. I've got a variable called column, and I've set it to 0 as well. Okay, I'll go into line 29. For row is equal to 0. I'll check that my row, which is 0, is less than max row, which is 2. It is, so I'm going to go into this loop. I'm going to go in here. Column is equal to 0. Yep, it is. And column is 0. It's got to be less than 3. Yes, it is. I'm going to go in here and print out whatever is sitting at row column. Row and column is currently 0, 0. Which means that I'm printing out this number over here. So I'll print out 1 and a little space. Obviously, it doesn't print the underscore, but I'm just putting it here so you can see that it's going to print out a space because I've got a %d and a space here. Okay, great. Then I'm going to increase my column by 1. So my column is now going to be 1. And I'm going to check the condition again. So I'm going to check, is 1 less than 3? Yes, it is. So I'm going to head straight into this for loop again. I'm going to print out whatever is sitting at row column. My row and column are currently 0, 1. So row 0, column 1, which means I'm printing out the 2 and a space. I'll go back out. I'll increase my column by 1, so it now becomes 2. And I test my condition again. Is 2 less than 3? Yes, it is. So I'll head in there, and I'll print out what's currently sitting in this two-dimensional array at 0, 2. So row 0, column 2 will give me number 3. And I'll print out number 3 and a space. I'll increase my column by 1, so it's now going to be 3. And I'll check my condition again. Is 3 less than 3? No, it's not. So I'm going to exit out of this for loop, go to line 33, print a new line. which means from here on I'm going to go to a new line, and then I'm going to go into this condition, the first for loop, and increment my row. So my row now becomes 1, and then I'm going to check my condition. Is 1 less than 2? Yes, it is, which means I'm going to go back into the for loop again. And so I'm back in here. My column gets reset to 0, and then I start again. So then I go, okay, I'll check if 0 less than 3. It is. So I'm going to go in here. I'm going to print out whatever is sitting at my row column. So the row is now 1, column 0. So row 1, column 0. That means I'm now printing out a 4 in a space. I'll go back out, increase my column by 1, and then I'll test the condition again. Is 1 less than 3? Yes, it is. Go into the printf statement and print out whatever is sitting at array row column, which is 1, 1. And at 1, 1, I have the number 5. So I'll print out a 5. Okay, I'll go back again. I'll increase it by 1. I'll check the condition. Is 2 less than 3? Yes, it is. I'll go back into the printf statement, and I'll print out whatever is sitting in that array at row 1, column 2, which is my number 6. So I'll print out the number 6. I'll increase my column by 1, so it's going to become 3. I'll check the condition. Is 3 less than 3? No, it's not, which means I will not go into the loop again. I'll come out on line 33. I'll print a new line, and then I'm going to go back into the for, increase my row by 1. It's now 2, and check the condition. Is 2 less than 2? No, it's not, so I'm going to exit out on line 34. And then move on with my life. Okay, so that's kind of how it kind of traverses through it and goes, you know, and moves through it. Yeah.
Why doesn't it reset row to 0 each time?
So if I were to reset the row to 0 each time, obviously I wouldn't be able to do anything. But the reason it doesn't is because it hasn't finished. It starts at row 0 and it goes until this condition is met. And increases it up until that condition, which is why it doesn't reset it each time. And that's why this column 1 is only reset once when it's reached this maximum. So when that reached the 3 and I came out of it, when I went back into the for loop to start with, that's when it went back to 0.
Okay, cool. So if that row thing was inside another for statement,
Then it would reset at some stage, yeah, when you called it in again. Okay. Let's do scanning into this situation here. I'll just erase. Okay, how about now we scan into this array, okay? Because, well, what use is it just to give it hard-coded values all the time? Okay, so if I were to scan into this, so what I'm going to do is I'm just going to comment that out. And what I'm going to do instead is I'm going to declare this array with max row and max column. Oh, someone said, why? Okay, can you explain the resetting again? Why is there a row 0 in the condition for the for loop? Okay, yes, so basically, standard practice, I could have just said, it's just easier for reading and for style, even though I've set it here as 0. I'm setting it here as 0 to show that I'm starting from 0, and I'm going to move up until row is less than max row. That condition is met. So that's why I'm doing it like that. Okay, so this for us then creates an array to start with, but it's going to be empty, and then we're going to need to fill it up. So it's going to create this array once that reads that, and it's going to be like that. Okay, and it's going to remain empty until we fill it up. So let's use scanf to fill up this array. Again, we need to move through this array, each index by each index, to fill them all up, okay? And this is when a loop inside a loop will become your best friend. And often it is so much easier to create shorter little things and then hand execute them, because you can see when you've made a mistake. Otherwise, it's very easy to get lost when you have a loop inside a loop, inside a loop, inside a loop, inside a loop. Okay, so let's try it out. So I'm going to now, in the loop inside a loop, what I'll do is I'll print out, please enter a number. and then I will scan into it. So scanf, and I'm going to scan a %d, and I'm going to scan into the address of my array 2D, and it's going to go into row column. Okay, I'm just going to comment that out for a second. Okay, so when it runs now, what it will do is it will scan into the array. So now if we wanted to print it out, and this is just getting to be very good, you know, for a function, it's just calling out to us, but now I'm going to print out here. So I'll just do it as 2 separate loops so you can see what's going on. Okay, do I need to print out? No, I'm going to not do that. We'll talk about it once I do it. Okay, here we go. So now we've got a similar piece of code, but it's scanning into as well. So let's compile it again. Okay, so let's run it. 1, 2, 3, 4, 5, 6. Okay, great. So everything is working great. There's like this random enter, which might actually look nice. Where is this new line coming from?
Coming from the tab of new line.
Yeah, so it's coming from here. Do I need this new line now? I mean, I could. I mean, it looks pretty, but I don't really need it. It's not serving any purpose because it's not actually helping me visualize anything better. It's not really doing much except doing those 2 new lines. Okay, so now there's no new lines here because I've just gotten rid of it printing the new line. It doesn't need to do that anymore. So all it's doing now is just printing it out straight away, 1, 2, 3, 4, 5, 6, and then I'll print it out. And then I'll print out whatever's sitting inside of that 2-dimensional array. Okay, Tom, could you just poll, please? Thank you. How are we feeling? Yeah.
How is it printing out the array?
I put a second loop inside a loop over here. Yeah, to print it out so that we can see that it's doing it properly. Yeah. Exciting stuff. Yeah, those are the vibes, yeah. How are we all feeling? 2D arrays. We're just starting, so feeling okay. The mood seems down. Oh, there's a poll. That's good.
More chocolates, higher mood.
Yeah, the more chocolates, the higher the mood. Oh, well, just throw some in. Let's raise the mood. I mean, you're all putting your lives in danger because Sophia is throwing, but...
Tom's throwing now.
Oh, Tom's throwing. Here we go. I'm judging both of you. Oh, Sophia, that was an amazing throw.
Thanks, Sasha.
What else do we got? We're running out.
What improvements? We're running low? It's okay. I'll purchase more for next. Hey? Oh, someone's in Wollongong. I love Wollongong. All right, there we go. That was a quick break. As Sophia literally did not hit a single person in the head. So that's... I know I did, but she just did some really good throws. All right. Okay, let's come back to this. Okay, let's have a look. I keep just putting red dots everywhere now. Okay, let's do this now. Declare and create a 3x3 2-dimensional array of integer numbers with the numbers read in from the user. Great, we've really almost done that. Then loop through the 2-dimensional array, printing out the values in the first row, followed by those in the second row, and so on. Now loop through the array to count the number of even numbers in the two. Actually, should we? No, let's just do this anyway. Now loop through the array to count the number of even numbers in the 2D array. And really, after the lecture, go out, take my code, and make a function out of it, honestly, because it's hideous right now. Okay, so we want to go back to a 3x3. I did a 2x3, so it was easier to draw it out. Okay, so we've got something here. We're scanning into the array. That's going to work nicely. Here we are printing out the array. That's going to work nicely as well. Shall we go through it and see how many even numbers we have in this array of arrays? Let's pulse through it. What do you think we need to do to traverse this array of arrays? Yeah, yeah. Yeah, just go loop inside a loop again. And okay, so let's do another loop. Struggle town. Okay, row, row less than max row. Row plus plus. And then I'll do my second one for column is equal to 0. You're going to get so tired just typing this out all the time. This is going to be like, this is literally the first assignment, the second assignment. I've moved you along. No, the first assignment. Okay, I want to move through this array of arrays. So this allows me to traverse through the whole two-dimensional array over here. And I want to check each element of the array whether or not it's an even number. How can I check that something is an even number? You've answered so many questions. In the middle.
I'd say it's modulus, and then 2 is equal to 0.
Yeah, okay, so if there's no... Oh, here we go. Just working hard for the chocolate. Then everyone will complain I've made them unhealthy or their teeth have holes in them. Okay, so I'm going to check if, and I'm going to check what's sitting inside that array 2D at row and at column, and I'm going to check if that item modulus 2 is equal to 0. Now, if it is equal to 0, then I want to have, which we talked about like 2 seconds ago, some sort of counter to count it. So I'll go up here and I'll declare a even counter, and I'm going to initialize it to 0, and it's going to count the numbers for me. So if it's equal to 0, which means that it divides by 2 perfectly with no remainders, then what I'll do is I will increase my even counter by 1. And that will count it up for me, which will be very nice of it. And then at the end, just so that we can see that we have actually done something, I'll put a printf statement to check it. The number of even numbers in the two-dimensional array is %d, and we'll have even counter. Okay, let's have a look. Okay, so let's compile. Okay, and let's run. Okay, I'm just going to be really not creative. Okay, so our array is 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's saying there are 4 even numbers in here. 2, 4, 6, 8. Yes, it's working. Okay, so that seems to be working. Should we run through it line by line, or how do we? Yeah. All right then, let's make it pretty. I almost did it as just DCC and then a dot out. So let's, small steps. Okay. Here we go. Now, there we go. No, I shouldn't have done that. Okay, excellent. Now it's looking much better. Okay, who wants to run through it line by line? Yep. Should we do line by line quickly? Let's do that. Okay. How about, no, it's happening. It's happening. This is going to get, that's a lot of loops. I'm like, how do I make it less loops? Hey? Well, I should move some of these into a function. The print should be a function. This could also be a function. So lots of these things, should we move something out to a function? Let's go through it, then we'll move it out to a function because it's hideous. Okay, here we go. Okay, first thing is I am creating and declaring a two-dimensional array that's got, it's a 3 by 3. So that means I'm creating something that looks like this. So 3 rows, 0, 1, 2 indexing, 0, 1, 2 indexing. and I haven't put anything inside it. Then I'm declaring a variable even counter, and I'm initializing it to 0 as well. Okay, on line 29, I've got a variable row, it's equal to 0 initialized, and I've got column, and it's also equal to 0. I'll go inside my first for loop. For row is equal to 0, so the row is equal to 0. Row is less than max row, so is 0 less than 3? Yes, it is. I'm going to go inside here. Now I'm in column is equal to 0. Is column less than 3? Yes, it is. So I'm going to go in here. I'm going to print out, please enter a number, and then I'm going to scan a number into it. So let's say I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9 again. So that means into my first one, I'm going to scan the first thing. So my row and column is 0, 0, which means I'm scanning into here. So I'm putting a 1 in there. I'm going to increase my column by 1 from this statement here, and then I'm going to check the condition again. Is 1 less than 3? Yes, it is. So I'm going to go in here, scan the next thing in, and now I'm scanning at 0, 1. So I'm scanning at row 0, column 1. A 2 is going to go in there, and I'm going to come back out. I'm going to increase the column by 1, check the condition again. Is 2 less than 3? Yes, it is. Go back in here and scan into row column, so 0, 2. So scan into here, and I'm going to scan the number 3. Okay, great. I'm going to increase my column by 1. It's now 3. I'm going to check the condition. Is 3 less than 3? No, it's not. That means I'm going to come out of this for loop. I'm not going to go inside it. And I'm going to go back out here and change this condition. So row is now going to be 1. And then I'm going to check the condition is 1 less than 3. Yes, it is. So I'm going to go inside here into the for loop again. I'm resetting my column to 0 from this statement. And then I start again. Is 0 less than 3? Yes, it is. I'm going to go in here. And now I'm going to scan into row column. So row 1, column 0. So I'm now scanning in over here. I'm going to scan in the number 4 in here. Change the column again to a 1, check the condition, and then scan into 1, 1. So scan into here now. So 5, and so on and so forth until I make my way through. Okay? So let me just fill it out because we've done a similar one, and then I'm going to go through and do the even for loop now. Okay, so let's say we finished scanning in. So now we've gotten to this part of the code over here. Okay? Now, in this part of the code, I'm actually checking for even numbers. So again, my row is equal to 0, so whatever was here is going to become 0. I'm going to check that 0 is less than 3, and then I'm going to go inside my second for loop. Now, column is equal to 0, and is 0 less than 3? Yes, it is. I'm going to go in here and check this condition. And this condition is going to be, is whatever sitting in this array at 0, 0, because row and column are currently 0 and 0, so is number 1 modulus, so is 1 modulus 2 equal to 0? No, it's not. So I'm not going to go in here. I'm going to go back out, increase the column by 1, so the column is now 1. And then I'm going to check the condition. Is 1 less than 3? Yes, it is. So I'm going to go in here and check this again. Is whatever sitting at 0, 1, so this number is 2 modulus 2 equal to 0? Yes, it is. So I'm going to go inside this if statement. And on line 53, I'm going to increase even counter by 1. So that's going to make it 1. And then I'm going to go back out, increase my column by 1, check the condition. Is 2 less than 3? Yes, it is. Going to go in here again and check. Is whatever sitting in my array at row 0, column 2, so over here, so is that 3 modulus 2 equal to 0? No, it's not, which means I don't go in here, and I'll just increase my column by 1. Check the condition. Is 3 less than 3? No, it's not. So that means I don't go into that if statement. I don't go into the for loop. I just come out here and increase the row. The row gets increased by 1. I'll check the row condition. Is 1 less than 3? Yes, it is. Go back in. Column is reset to 0 from this statement. And I'll check the condition. Is 0 less than 3? Yes, it is. So I'm going to go inside here again. I'm going to take whatever is sitting at row 1, column 0, so this number here, and check what happens when I do 4 modulus 2. Is that equal to 0? Yes, it is, which means I go into the if statement on line 53, and my even counter goes up by 1, okay, and so on and so forth. I keep going through the for, a lot of looping. Okay, how is that? Tom, did you run a poll? How are we feeling? And have you answered? There's a lot of questions here. No, there's no. Oh, okay. Oh, it's gone. Sorry. No, I'll just scroll up. How is everyone feeling about two-dimensional arrays? Yeah. Oh, that's great. Thumbs up. I thought it was like a hands up, thumbs up. Okay. It's like, I don't know. It's an array of arrays, I guess. You can do 3D arrays. You can have multi-dimensional arrays, but we're not going to do them in 1511. We stop at 2.
Is this the only way to declare Fourier? As in, is there a way of saying something like, so the normal array declaration goes in, say, array square brackets 3, right? Can we say something like in array underscore 2 square brackets in array 3 or something?
Oh my God, there's also like dynamic memory allocation, which I tried to do last week and it got out of, last term, and it got out of hand, so we're not going to do it. So it's like you're trying to give memory at runtime as opposed to compile time. Array memory is given out at compile time, which is why we have to specify the size of it.
So with dynamic, is it not stored next to each other?
It is stored next to each other, but it has to, but it can only give it, it can only increase it by doubling it, or like give it an array that's exactly the same size. It can double the size of it. It can't give it by 1. All right, I think we're going to finish there for today because it feels like a good spot. But let me know how you feel about today, and if there's anything we can do for Thursday, just let me know on the feedback. That would be great. Thank you, everyone. Have a great week 4. Enjoy assignment 1.